Okay. All right. So yeah, so I mean, like I said, I mean, don't feel like scared or discouraged by this. This is hard, right? This is, coming up with this idea is hard. It would take a lot of trial and error and playing with the numbers. But yeah, so we want to kind of go in reverse of this. So we know we've got the code val, which is, let's say it's A, right? So that's 26. But it needs to be what? It needs to be 97 is the ASCII value. Okay, guys? And they're all going to be going up. So for instance, for B, it's 25, right? But the ASCII value would be 98. So if you notice, it's going up. Okay? But here it's going down. So maybe if you start at 27, 27 minus 26 gives you what? 1, right? Now, if we do this one over here, 27 minus 25 gives you 2. Yes? If you notice, now this is going up by 1. And then these are going up also by 1. Do you agree? So then what's the starting number? And then you're done. $96. Yeah. So if I do 96 here, 1 plus 96 equal 97. Okay. 96 plus 2, 98. Do you see that? Now, I asked you, this is hard, right? That's the whole point of this exercise. This was a hard, elaborate crypto, yeah? Cipher. Very tough if you want to think of it that way. Very, very tough. Is it secure? No. So making something elaborate does not make it secure. Okay? It's not secure. All right. So and how do you know? You know already how to quantify if a cipher is secure, because we said if you can tell something about the message from the cipher, it's insecure. We were able to see, I think it was T repeating and things like that. Got it? Any questions about that idea? All right, good. So now that we've figured it out, we're going to go over here and just write it out. So should be the general formulation for this should be 96 plus, and then we just need the difference. So 27 minus code val, and that should work. Okay, so 27 minus code val plus 96 should give us what we want, right? The reverse of this. So now we send back plain code, which is underscore. Got it? All right, good. So we have this part hopefully working. So now we're going to go back to where we were, which is the decrypt function. And we get an ASCII val, which is what we want, right? An ASCII val. But what we need is the letter. So at this point, to get the letter should be pretty straightforward because we already showed that there's a built-in function that interacts with the ASCII table called CHR. So we just give it ASCII val, yeah, and that's gonna give us this. Oh, this can be the letter actually that we want. Perfect. And now we just want to concatenate all the letters into something. So let's call it plain decrypted. Plain decrypted. Why not? We need to initialize this one to blank. And we're just going to concatenate these in here. So I'm just going to say plain decrypted right? Equals letter. Is that it?
Equals plain decrypted equals letter.
Okay. So plain decrypted plus letter. Yes, very good. So we accumulate this and now we return this. Okay, guys? So I'm going to go ahead. Plain decrypted, just like that. And we should get our message back if everything works. So I'm going to do Control X, Y. Gonna run it. Ah, did it work? Yes, right? Because we got our message back. And today is and the spaces, that was not an issue. That's great. Any questions? So this is basically the problem. I'm just going to add a little bit of code now so that we can make it like you can take an input from the command line and basically encrypt whatever you want, and it's going to decrypt it. All right, so this is the example. As I said, kind of illustrates a lot of the steps. I will load up the code on GitHub if it's not there already, and then obviously the video. On Thursday, what I need to show you is how to do the XOR operation, right? So we need to do the XOR operation in Python because you're going to have to take strings and convert them into sequences of bits and then do the encryption at the XOR level, right? And then we're going to try to implement an algorithm for integrity. So that should be a pretty straightforward thing. That one, in theory, should be pretty easy, right? And yet that one is secure. This one, more elaborate, more complicated, it's insecure. Get it? All right, so let's add, but that'll be on Thursday. Okay, so to wrap up today, let's, so that concludes this code. So we're gonna do one final test by reading in any string, right? So we're gonna type up a string on the command line and encrypt and decrypt, okay? So let's go ahead and modify our code for that. So how do we do that? So that's going to be in our main section. Okay, so instead of doing this, I'm going to comment these two out. And, I'm just going to write a message here. I'm going to say print, please enter your message to encrypt. Okay, so then we're gonna do plain text input. All right, and that should work to allow us to enter some string. Then that string will be encrypted and decrypted. So let's go ahead and try that one. Okay, clear. Run it now. Okay, so give me some sentence to enter, something short, please.
How are you doing?
How are you doing? Okay, how are you doing? Question mark. We didn't really plan for a question mark. It still works. The beauty of using that equation, right? So, because that question mark is a so it's a character on the ASCII table. How about numbers, right? So let's run this. Today is September. Today is, oops, no, hold on. Today is Tuesday, right? Tuesday, September 5th or 5, comma, 2023 at 5:30 p.m. Right? Did it work? Worked as well. We didn't plan for numbers, and yet they're all ASCII characters, so it kind of works as well. Got it? So that's basically the idea, and that's the code example that we were going to do for today. So with this one, all I want you to do, I will ask you to just submit this as an assignment. Just show screenshots, if anything, just to make sure that you can get it to run, okay? Very important that you do this exercise, try to understand everything. Pretty much that covers all the coding that you'll need, okay? I mean, literally. We don't need anything more advanced. Maybe a dictionary here and there, but Python is pretty simple, okay? And so everything else that we do in the future, will be kind of that same format. Obviously, the logic gets harder sometimes, but then, we'll probably just use the function, and kind of ignore all the specifics because it'll be just intricate, okay? Any questions? All right, so I'll create a link a little later for you guys to submit this as an assignment. It's just, create a PDF report, screenshots of some of the code, make a few, you don't have to include everything, a few comments, code is short anyway, and then please just run a scenario. Any kind of like we did in the end, some encryption and decryption. Got it? Now practice this on Thursday. You will get a problem that you have to solve on your own. So I will describe the algorithm on the board, and then you guys will implement it. The only thing I will demo is how XOR works, basically. So it's like you'll have to tie that and this and build something. Got it? All right, so I'm going to go ahead and pause the recording now.